going to do area and volume, right? We'll start with two-dimensional shapes because that's
Sure.
what we're all talking about. And in that case, you have area and perimeter, right? Area is basically how much space the shape takes up. Perimeter is how long it takes to go around the shape. Pretty simple. So for a triangle, you're going to be writing these formulas, Graham. Triangle area is 1/2 base times height. Area equals 1/2 base times height.
Area equals 1/2 base times height.
And for every shape for a polygon, perimeter is just add up all the sides. It's not that hard. So, okay, so now we're going to area of quadrilaterals. Now, first we're going to do our type 3, because type 3 was the rhombus, square, parallelogram, and rectangle, right? So they all have the same area formula, and that's area equals base times height.
Easy.
Mad easy. About as easy as it gets.
Okay.
And then perimeter, again, add up all the sides.
Yep.
Not very hard.
Okay,
now this is the one that I'm just subtly looking up behind my back right now, because I always forget the area formula for type 2s, which is trapezoids. Trapezoid area is area equals 1/2 times height, parentheses a plus b, parentheses.
All right. Get a little trapezoid going. 1/2 times height.
And then parentheses, and then do like b sub 1 plus b sub 2 or something.
B sub 1 plus b sub 2.
Yeah.
And b sub 1 might be this one up here, and b sub 2 might be that one up there. And height.
Exactly.
Would
you
be that.
draw in the height with a dotted line. Yeah. Good job, Graham. That's it.
Thank you.
And how do we do perimeter? Add
it all up.
Out of all the sides. Yeah. It doesn't get any easier. Okay. Oh, it's actually mad easy. So see your picture of your kite?
Yep.
Yeah, so the two dotted lines, name one D1 and name one D2.
Okay.
And then the area of the kite is just 1/2 times D1 times D2.
D1, D2.
Mad easy.
Area equals 1/2 D1 plus D2?
No, just 1/2 D1 times D2.
Sweet. I put in some extra parentheses there, but you know what we say? Say it with me. There's no such thing as too much parentheses.
Yeah, I mean, I would say too many parentheses, but that's okay.
Sure, but you know, that's not an English podcast.
English class podcast. This is for math, so we don't even have to do good grammar.
Right.
There we go.
Oh.
Yeah, where's your thing, Graham?
Right here. I was on my iPad.
Sick. Ignore it. Basically, what you can do if you're ever like not sure about how to do the area of something, cut up your polygon into other shapes that you
That's a really good point.
The area of, and then find those areas and then add them together.
You know what? You just described a pretty advanced and useful concept of, oh, you've got a problem you want to solve?
Let's go on to a new slide and show an example.
Sure, and I'll speak at a high level. Say you've got a problem you want to solve, but man, that looks really hard, and this could be, you know, it could be life, could be relationship troubles, could be,
or like,
you know, your car's breaking down.
You need to find out how the area of your farming field or something, but it's a really weird shape. Sure,
and that's a very math term, but you know, life can be broken down into smaller problems. You solve them one at a time, sum them up, and there you've got your solution to the overall problem. But yep, let's we'll stop talking about life and get to some math.
Our weird field, because like there's a creek that runs alongside the property maybe, and your neighbor's being a jerk and refusing to sell to you, blah, 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 blah. Yeah, so then you have that. So then
2 triangles.
That's another way you could do it. Okay. Yeah, and then you just have to find the base and height of each one. So just identify those on your drawing, Graham, so everyone knows what's what.
So we've got base, oopsies. Got height there. We've got base. 1, 1. And then now base 1 is equal to h2. And then this is equal to base 2.
And that only works if that's a right triangle there.
So let's make it a right triangle, because this is math, and there are no rules.
Yeah, but that would not be base 2, Graham. That would be the hypotenuse. So that's okay. Just erase it and make the only other side the base.
But then why is base 1 not the hypotenuse? What's the hypotenuse? Our listeners don't know what a hypotenuse is, and clearly
the first triangle isn't a right triangle. So I'm pretty sure only right triangles have a hypotenuse. And a hypotenuse is the side of the triangle that is opposite the right angle. Okay. I was right.
Okay. And so then, but why is this long line here base 1?
Because it's the base of the small triangle.
You just defined it with the name. What is a base?
I don't understand your question, Graham. What are you asking?
What makes a base of a triangle?
Oh.
This is the comedy part of the podcast.
It's perpendicular. It has to be perpendicular to the height.
Oh. There you go. You learn something new every day.
All right, so yeah. And the rest of this problem is easy. You just do 1/2 base times height, you do it twice, and then you add everything together. Blah, 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 blah. We're done. All right, let's move on to some 3D shapes, fam.
Beautiful.
In 3D shapes, it's not just area and perimeter anymore. It's surface area and volume. So volume kind of corresponds to area, and surface area sort of corresponds to perimeter, if you like to think about things conceptually, but it really doesn't matter at all. So just ignore that. Anyways, the surface area, let's see. Say you have a cube. You have any sort of 3D shape. The surface area is, you take the area of each side of that shape and you add all those areas up together, and then you get the surface area. So kind of like I was saying, it's kind of like a 3-dimensional perimeter, if you like to think about things like that. Volume is how much 3-dimensional space a shape is taking up.
Sure. So we've got a cube here. You're saying if I take the surface area of each side of this cube by doing area is equal to base times height for the front,
because each side,
this side, this side, this side, this side,
each side of the cube is a 2-dimensional shape. So then you're back to
right.
Of like finding area of a 2-dimensional shape.
So basically, you're going to do this area 6 times for all 6 sides of the cube. And that'll just get you the surface area.
Yeah, I mean, since we're dealing with the cube, like another option would be to find the area of one side and then multiply it by 6. But
sure.
If you want to add stuff up individually, go right ahead.
Yeah, and you're touching on something that me, as somebody who dabbles in computer science, gets to. It's you're talking about computational complexity, and sometimes you want to reduce that. If you've got, your brain is a processor. It processes calculations just like a computer processor. And, if you're writing some lean software, say on a implantable device or on a satellite, you want it to be really efficient, work really well. So why would you do, oh, let's repeat this summing process 6 times if well, it's a cube, all these sides are the same, just do it once, then multiply it by 6. Bingo, bango.
Yeah, basically, what Graham is saying is that when you're doing math, you want to think about the problem before you do it so that you end up doing the least amount of work possible.
That's right.
Yeah.
That's right. I mean, we clearly think the same way.
Yeah. So like this is for a cube. For a rectangle, you could, for a rectangular prism rather, you could find the area of like 3 of the sides and multiply each of those by 2, and then add everything up, and then you'd be good to go.
Sure.
But it also just like depending on if it was a rectangular prism where like there were 4 congruent sides going around, then you'd multiply it by 4. But you kind of have to look at the specific problem. And
yep. Every problem is different in math. No 2 problems are the same. No 2 calculations, even if you do, 6 times 8 one day, might be a different answer the next day. And that's math.
And if you take an extra second at the beginning to think what is the most efficient way to do this problem, you're going to save yourself hours of work down the line. So,
Margaret, I think you missed a little test that I put in there for you. I said that 6 times 8 one day is going to be a different answer the next day.
What, Graham? Why would you say that?
To see if you're listening.
I was not.
To see if our audience is paying attention too.
Oh my gosh. Graham, it's 48. Just
always and forever. And that's the beauty of math. But there are many ways to interpret questions.
Here we go. Volume of a tetrahedron. Do you know what that is?
Oh my gosh. Are we not going to save anything for episode 2?
Graham, there's a lot of math left. I don't know what you're talking about. We're talking about all the math in the whole world. A tetrahedron, it's like you take 4 triangles and make them into a 3D shape.
That sounds lovely. Let's put a pin in the recording of this episode for now and record the rest of it later because I've got a brunch to go to.
You have a brunch?
A brunch.
What are you brunch with? Is this a Hinge date?
No. Margaret, we're still recording.
I know, Graham. I asked that question intentionally.
Wow. So our listeners can understand who we are as people. Oh, they're not just math experts.
Ew, Graham, shut up. I just know.
What, nobody thought that?
I wanted them to make fun of you for being
I'm going with my, you know what? I'm going with a friend who, it is Eid right now. For those who don't know what that is, it is the celebration at the end of Ramadan.
Oh, Eid al-Fitr or something?
Okay, well, maybe we won't include that part to, pay respect to our Muslim listeners. But I'm going with a friend who knows quite a bit about math. He's currently in medical school, and, we went to the same high school together. Shout out Connecticut. And yeah.
I hate everything. Okay.
Let's break this into a part 2.
We will see you all next week.